Hello everyone and welcome to another class of DECT. In our previous session we have discussed about the introduction to digital enhanced cordless telecommunications. Now let's move further into what is DECT and how it works. All the new radio interfaces which are based on various paradigms, like they are able to offer required data rates, propagation characteristics and also the spectrum efficiency. And these parameters are necessary for the IMT 2020 and DECT 2020 use cases. This basically maintains the compatibility with the carrier and the time structure with the already used DECT band, DECT band. So basically what happens, so with the help of DECT 2020, which is now a part of 5G standards which are developed by ITU, so this basically DECT 2020, it promises like it can fill a gap in wireless IoT market for massive machine type communication. Like we can have an example of self-driving vehicles in factories, high-speed robots working alongside with human operators in warehouses, and critical infrastructure for various utilities in buildings and cities. So if we talk about in terms of wireless Internet of Things, all the applications need ultra high reliability and low latency of a wired like Ethernet. So even at a massive millions to billions of the node scales and also at low per node cost and cost efficient self-organizing networks, they can make this thing possible. So IMT 2020 has three usage scenarios: enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. So it has three technical performance requirements: that there should be peak data rate, peak spectral efficiency, user experience data rate, fifth percentile user spectral efficiency, average spectral efficiency, area traffic capacity, latency which is of user plane, control plane, connection density, energy efficiency, reliability. Other than this, there should be mobility interruption time, and bandwidth. These are all the three technical performance requirements as specified by IMT 2020. So in addition to these, there are general, like we can improve the range as compared to the legacy, the old one DECT. We can improve voice quality compared to the legacy. We can improve the data rates and we can improve the number of simultaneous connections also. So DECT 2020 should be able to coexist in the same area with the legacy DECT system. They are operating over the same spectrum and should implement the proper channel selection rules to mitigate any type of interference. DECT 2020 new radio operates in a global license and exempt 1.9 GHz band, which means that you can set up a network without frequency planning or spectrum leasing cost. Since this 1.9 GHz band is globally available, so it also enables utilizing a single radio hardware version of use everywhere. DECT new radio is completely non-cellular and does not require cellular mobile networks or the existing infrastructure like base station to operate. With the help of DECT 2020, we can simply build our own private wireless network in which every node can be an access point with the direct backhaul connection to the internet. In DECT new radio 2020, this terminology is like sync node. We call it as sync node. So the lack of the centralized setup and the operation, it immediately enables self-organizing and healing mesh networking wireless topologies. So it should be possible the implementation of compatible devices, FP or PP, which implements both the DECT 2020 and legacy DECT radio interfaces. So it has various design choices that the basic radio access technology is orthogonal frequency division multiple access, and the channel access is TDMA or FDMA based. DECT basic time frame is of 10 millisecond, and this is same as the legacy DECT system, and the basic frame split is of 24 time slots. FPS mobile terminals is described as, here I have mobile terminal as PP and base station as FP in this. DECT basic time frame is of 10 millisecond. Basic split is also 24 time slots. The basic channel width is 1728 megahertz, and data rates required for higher order modulation as 1024 QAM. Here there is a use of MIMO for better data rates, increased reliability and efficiency. Also there is a backward compatibility consideration that over the existing DECT 1880 MHz to 1900 MHz spectrum, over the other bands like adjacent or non-adjacent with the DECT band, or we can have a combination of both. So when operating over the DECT band, the design of this new technology should take into account the operation of existing DECT devices. DECT 2020 will use the same basic carrier and the spectrum structure. The elementary carrier is of 1728 MHz and slot is defined as 1 on 24 of a 10 millisecond. It foresees the use of both the half carriers and half slots. The supported data rates range from 120 kbps to 1872 mbps with single input, single output, and up to 11232 gbps with MIMO configurations. Now with the coexisting with the legacy DECT and other nearby DECT system, the coexisting rules cannot require that the different systems should be synchronized to the same time reference. Here the high average spectral efficiency is achieved by using a combination of MIMO, beamforming and multi-user techniques. Thank you.